Good morning. So we're back here in the second part of the revision series. We're working on the revision on cycles. Now for those who are new to this, you might have missed the previous video. We started off with revising the questions on diversity. Alright, it is from the mid-year exam paper 2021. We went through the question 1 and question 15, as well as question 35. Now, in this video, we're moving on to the cycles, revision on cycles. So we'll be going through questions 2, 3, 4, life science cycle questions, as well as questions 16, 17 for physical science questions. Now, we may or may not go through the open-ended questions because these questions I would like to leave for us to revise when school reopen in class, because these are open-ended questions and you may have more questions that you want to ask. However, if the questions are simpler, I may go through it here. We shall see. But the focus today will be on cycles and on the MCQ questions. So let's get started. As usual, do pause the video when the question is being shown to you. Try it first before you look at the answer. That's the best way. And an even better way is just do a quick revision on the topic. For instance, if we look at question 2, this question is about germination. So it'd be better even if you can just pause this video, go and read out quickly on your P5 Cycles textbook on plant reproduction. Spend 5 minutes, just flip through the pages, read through it. And before you attempt this, that will make sure that your vision right now is, your brain is full of the ideas and the concepts before you attempt this. Right? Pause the video and try it. Okay, let's start. Now, Megan carried out an experiment on the germination of seeds as shown in the 2 containers here. She observed that the seeds in container A germinated, but not the seeds in container B. So which of the following variables is likely to be the cause for the seeds in A to germinate, but not the seeds in B? So what are the conditions for germination of seeds? So I'm sure you've learned this thing called the water, oxygen, and warmth. Of course, your book would say suitable temperature. But some seeds can germinate at quite low temperatures, but if it's suitable for the seed, so suitable temperature. But we accept warmth, okay? So which of the following variables is a likely cause for it to germinate? So in other words here, these two have some similar conditions, but it's missing, one of them is missing one of them. So B is missing one of them. That's why the seeds in container B did not germinate. So what could it be? Does both have water? So I see the word wet, cotton wool. And this is obviously wet because it is right under water, right? So yes, both of them have water. Alright, A has water, B also has water. How about warmth? Where are they placed? I'm not quite sure where are they placed, but the question didn't state exactly where, but they seem to be in the same spot. There's no mention like there's a sun here, no sun here, or aircon room. Alright, they didn't mention that, so I'm going to make an assumption. I assume that they're at the same place. If they're at the same place, then I assume the temperature would be the same. And I also don't see things like ice cube anywhere, or on top of a hot plate, or on top of a flame. So all these things are absent from the 2 pictures given to me for making comparison. So I'm going to assume it's the same. Now how about oxygen? Now here clearly, this part is the air. So oxygen is part of air. So I'm very sure here there is oxygen. Here is different, right? The seeds are covered with water. They're practically drowning inside. And there's a layer of oil. So oil will stop any oxygen from the air from dissolving inside the water. So there isn't oxygen here. So what is a variable that is the cause for the seed in A to germinate? Of course, for the seeds here to germinate, it must have all 3, right? But since you're making a comparison, the one that allows this to germinate but not B is the presence of oxygen for A, but the absence of oxygen for B. Now there's no oxygen here. The best possible answer here will be air. So for question 2, answer is 1. And for my class, this is there are a few of you who got this wrong. So the few who got this wrong, do make sure that you are able to understand this. Alright? Let's go on to question 3 now. 3 is here. So again, I'd like you to pause the video, quickly read up about pollination, about fertilization, alright, about fruit formation, and then come back and solve this. So pause it now. Okay, let's start. Now some students wanted to find out which parts, right, W, X, Y, or Z of the flower shown below were needed to develop into a fruit. They removed 2 parts of the flower, then they transferred some pollen from another flower of the same plant. Okay, so same species of the same plant, right? So the species might be the same, it's on the same plant. So plants often have more than 1 flowers on them. To the remaining 2 parts of the flower. So there is pollen being transferred over. So after some time, they observe that the flower has withered and a fruit was formed. Oh, fruit was formed. This tells us that fertilization has happened. Transferring pollen. This tells us pollination was done. And if pollination was successfully done, then fertilization will happen. A quick revision on the cycle, right, of flowering plant reproduction. You would have a seed, and when the seed is being dispersed, after the seed lands somewhere, right, it starts to germinate. After it germinates, it grows into an adult plant with flowers. Then once you have a flowers ready, alright, you can start to pollinate. There are of course different kind of pollination. There can be pollination by wind or by animals. Alright, so we're not sure which one because this is not what the question is testing. And if pollination is successful, you will go on to fertilization. That's when the fruit start to form, the ovaries start to swell, the ovules become seeds. And when that happens, you have your fruit forming, okay? And your fruit forms, eat it, and they will disperse it. And pollination is a movement of pollens, alright, from one flower, from the anther of one flower, to the stigma of another flower of the same species. And that flower can be on the same plant, can be on a different plant, but same species. So in other words, for this to happen, pollination must work and fertilization must have happened. That's why you have fruit forming. Therefore, the parts that must be present, right, must be your stigma must be there, the style must be there, and of course the ovary with all the parts inside, the ovules must be there. And all these you will notice are the female parts of the flower. Okay. How about the anther? Do you need an anther? Not on this flower because I already said the pollen is from another flower of this, on the same plant. So the part that must be kept must be X is the stigma. Okay. And Z is the ovary. Do I need the petals? No need. Do I need the anther of this flower? No need. So it's X and Z. Alright, so answer for question 3 is 4. Did everybody get this right for this question? Question 3. There were still some mistakes, okay? That one of you make this mistake. So when you get a booklet A back, do check if you are the one and then take a look. By the way, those from my other class, right, my Grace, this is from Kindness. Those from Grace, right? Notice I'm not showing this because the analysis is mixed up. The analysis is for 32 students. So both Mr. Ong's group and my group are all mixed up together. So this analysis for my 6th grade class, I can't use it to highlight to you because the results are mixed and I'm only teaching 22 of you, not the whole 32. So just in case you think Mr. Ong has forgotten about you, Mr. Ong did not forget my 6th grade. Alright, I just cannot use this item analysis report churned out from the computer for this. Okay. Now let's go on to question 5. Question 4, sorry. Now this question is about seed dispersal. So if you have not revised seed dispersal, can you pause the video and read out the question on seed dispersal, the chapter on seed dispersal inside your P5 cycles book? Okay, welcome back. The diagram shows fruit B. Which of the following graph shows how the strength of the wind will affect the distance moved by fruit B? So this hair-like structure always tells you it's there to catch the wind. So it can float and stay in the air for a longer time. Why? So it can travel further. Alright? From whom? The parent plant. You want to be traveling further from the parent plant so it doesn't have any competition. You want to reduce competition for 3 things, right? We've gone through many times. What are the 3 things? So remember the expensive car is called BMW. Our car is different, it's our LMW. Reduce competition for light, for minerals, and for water. Okay, just these 3. Which of the following show how the strength of the wind will affect the distance traveled by fruit B? Since it is meant to catch wind, right? Of course, the stronger the wind is, the further it travels. Okay, so I should expect to see the distance traveling to go up as the strength of the wind increases. So the graph should be this kind of pattern going up. Okay. Now this one, but I'm not going to say 4 is answered straight away. I'm just going to look through all the rest. This kind of graph tells me it's always useful to put in some numbers. Let's say I put in 0 here. This part is always 0. Let's say I'm not sure how to measure strength of wind. It's usually by wind speed, like knots. Okay, but here let's put on 10 units, 20 units, 30 units, and 40 units. Imagine you're saying here for this graph, those who chose this, right? Oh, at 40 units, the distance traveled by the fruit is 0. This is 0. When the wind is weaker at 10, it travels further. Distance is further. Doesn't make sense, right? This doesn't make sense. This one makes sense up to this point. The stronger the wind, alright, the further it travels. This part doesn't make sense anymore. Alright, it means that after this point, the stronger the wind, the less distance it travels. And this one is basically telling us, alright, that the strength of the wind does not affect the distance moved by the fruit. Doesn't affect, no matter it's this strength or this strength or this strength here, the distance traveled by the fruit is the same all the time. Doesn't make sense. So by elimination, I can get the answer is 1. Even if I don't, I can get the answer here. Okay. Now you will notice the interesting part. The answer is 1 for this question. The interesting thing you will notice is this part. Even when the strength of the wind is 0, the fruit will still be dispersed a bit away from the parent plant. Because it is still floating away, alright, and there will be some air currents no matter what. A little bit, it's not strong wind, but a little bit, and that's why it can travel a little bit away from the parent plant. If you think of it, even if there's no wind, it falls down directly, okay? The tree with a huge canopy, for instance, if the fruit is here, it falls here. Yeah, this is a distance away from the parent plant. Because the roots is where it will be competing for water, right? When it starts to germinate. Okay, anyway, for question 4, the answer is 1. Any more life science question? But that's all for the life science cycle question. Now let's go on to the physical science one. So physical science will be question 16 and 17. So physical science cycle question will be on water cycle, matter, and states of matter. So I'd like you to look at your water cycle chapter now. Read through the part about boiling, melting point, freezing point, evaporation, and then you come back to this because we're going to work on end rate of evaporation. Okay, read out your chapter on water cycle now. Pause the video, or you can come back later. Okay? Alright, good that you have revised. I hope you have done so. Now, the graph shows the changes in the temperature of ice and/or water in the beaker over the time throughout the experiment. This is used because throughout what's happening here, they talk about ice at some stages, and then beyond that, when all the ice has melted, you go on to water. Therefore, it's ice and slash or water. So which of the lines above show that ice or water in the beaker was gaining heat, and which show whether ice or water was losing heat? Even my P5s who are using this for revision, you can also talk about this because we have already learned this in term 2. Okay, let's do a quick recap. Talk about solid, liquid, and gas. And of course, there must be a gain in heat for solid to change to this. And that temperature is known as the melting point. So you see melting happening here, right? And during the stage what we call melting, what happens is that the temperature will not increase. So the ice melts from, let's say, an ice cube, melt to less ice and more ice, water, melt to even less ice and more water. The temperature for ice here will still remain at 0 degrees Celsius, like as for the ice water. Only when it has fully melted, now it's only left a puddle of ice water at 0 degrees Celsius, only at this point will the temperature start to rise. Before that, whatever heat you supply is meant to only help you to melt the ice. Whatever heat supply at this stage, at this stage, at this stage is not meant to increase the temperature of the matter, but it's meant to increase, it's just to help the ice to melt. Only at this point, then the heat that is supplied to the water will now cause the temperature to rise, of course, cause a change in state. And from here onwards, the change in state will be to a gas. This part is from liquid to gas, and the gas is water vapor. This is known as evaporation. And here you did not notice 100, right? So therefore, there's no boiling happening here. Boiling of water only happens at 100 degrees Celsius. Now, so this point here is where it starts to evaporate. So this is the evaporation. And both of these involve heat gain, right? Heat gain. Temperature doesn't increase, but heat is gaining to melt it. So melting doesn't happen at AB. So AB is part of the answer. And BC, temperature is rising because the water here is gaining heat. So BC, definitely part of the answer. Okay, so I can't get the answer just by looking at heat gain. I'm also going to heat loss. Now heat loss is when the temperature starts to drop. So we are looking at temperature from 70 drop to 30. Here, there is a drop in temperature. It must be cooling off. Heat is being conducted through the water to the environment, lost in the environment. So CD definitely is where heat is lost. Now, what is DE? Notice that DE here, the temperature remains unchanged, flat line, right? So right now there's no heat gain nor heat loss because the temperature of the water at DE right now is exactly the same as the room temperature of this room. For this room that this experiment is conducted in, the temperature is at 30 degrees Celsius. So DE, no heat loss. Therefore, the answer here is 2 for question 16. Now, did everybody get this right from my K class? No, question 16. There are still some students who make mistakes. 4 of you make mistakes, okay? So please, these 4 students, make sure if you still don't understand why you got it wrong, come and watch this video once more. Let's talk about rate of evaporation. There are a few factors that affect the rate of evaporation. Let's recap. The one they talk about exposed surface area. For example, if I give you a container like this, or like this, or like this, okay, and if I tell you this one here is 15 cm, this here is 13 cm, this part here is 1 cm. Of course, the smallest exposed surface area would be container C. Now the largest one will be container A. But of course, we haven't come to the kind of tricky question because notice the exposed surface area for this container will change as the water level goes lower and lower. This part here is actually smaller than this part. But that's for another question. Other exposed surface area, the wind condition will also affect. So when you put it either in a field or you put it in front of a fan, okay, right, when there's wind, that will increase the rate of evaporation. Or the last one is heat. Heat means put it in a field in the daytime so there's a sun, or you put it near a heat source, right, on a hot plate. Then you start to heat up the water. So with the source of heat, that can also increase the rate of evaporation. Let's take a look at this. So we want to find out here, Lily want to find out how the rate of evaporation is affected by exposed surface area. So therefore, this must be the only changed variable. If you've gotten this wrong, it also means probably your understanding of conducting an experiment is not so good. She poured some water into 4 containers made of the same material. So the same material means their conductivity, the heat conductivity is the same. Right, so you can say, oh, metal conductor conducts heat from the environment better to the water compared to a ceramic one. So that is not part of this, right? This person is trying to control, make it a very fair test. But we're not sure about the shape. Shape is not given to us. I'm going to assume the shape is the same right here because the shape will affect the exposed surface area. If the shape is the same, then exposed surface area is the same. So maybe the shape is different. I don't know. The table shows the different condition. So room temperature must be kept the same, right? So I see 25, 25, 25. I'll be looking at these 3. I will be most likely ignoring anything with Q. Because the only change variable must be exposed surface area. And temperature is an indication of how hot or cold a place is. Alright? So anything with Q will mean that the water there is at a different temperature. So I'll ignore Q totally. So go to Q, straight away you know it's out. Next one. Since exposed surface area, I need to look at things that are different. So we compare either R with S or P with S. I want to compare P with R because P with R is 40, 40. Exposed surface area is the same. Then there's no point, right? Because it's supposed to find out how the rate of evaporation is affected by the exposed surface area. Is there any P and R? Let me see. P and R don't have, okay. So the amount of water at the beginning must be the same as well, right? So same amount of water. So, okay. So P and S, same amount of water. I cannot use R because R, the amount of water is different at the beginning. So, I got the answer already. It's P and S. Now just to be very sure, I must check wind condition. Same wind condition, windy, windy. Same wind condition. Same volume of water. Alright, same room temperature between P and S. Same room temperature, same volume of water, same wind condition. Only difference is exposed surface area is different. So did everybody get it right for question 17 from my class here? Everyone except one of you, okay? This person. Going to find out what's wrong with your understanding, alright? Now let's take a look at, that's it for booklet A questions on cycles. So revise something on water cycle, revise something about heat and changing of states. We also revise something about germination and on seed dispersal and on pollination and fertilization. Alright, I think we'll stop here for cycles. And then on the next day, I'll release another video which will be on the next theme. So if you want to revise the next theme, so far I'm going in order. Let me just show you this. Going in order of, we've gone through diversity already and cycles. Next one will be on energy. I'll see you on the next video for energy. Bye.